Okay, after importing everything we need and making the initial settings, now it's time to see the code that provides the actual functionality of this application. First, I defined three variables, which are initially empty lists. We'll see their role soon. Next, I defined the function that takes care of the DHCP sequence, meaning generating client packets and receiving server packets. Okay, using global all given lists, I made this variable available in the global namespace of the application, so other functions can use it too. Let's keep this piece of code for now, and we'll get back to it soon. Now if we look up here to see how a DHCP packet looks like, you can see there are a ton of parameters and fields and values for each packet type. But the good news is that you don't really need all of them to generate a valid DHCP discover or request packet. And Scapy will send your modified packet even if you don't totally follow the format in which it was captured and displayed to you using the Scapy command method. However, in a DHCP transaction, there are several parameters that you should definitely include in your packet in order to be a valid DHCP packet and to receive a response from the server. For example, let's take this packet I've created right here. This is a DHCP discover packet, but the same parameters must be defined in a DHCP request as well, with a minor difference. When comparing the DHCP discovered I captured up here, this one, with the one I defined down here, you'll first notice that I have really eliminated a lot of uninteresting stuff from the packet. Actually, I only kept the mandatory parameters like the destination and source MAC addresses that you can see right here, the DHCP source and destination ports in the UDP layer. Then in the bootp layer, we have up equals 1, which means that it is a bootp request, XID, which is the transaction number. This is a random identifier for a single DHCP transaction. Then there is CHADDR, which is the client hardware address used by the server to determine the right parameters for the client. Finally, the DHCP layer needs an option that specifies the message type, discover in this case, or request down here. Okay. And this is actually the minimum number of options and values you need to send a valid DHCP discover packet. Now I promised I'll get back to these variables right here. XID will actually be the transaction identifier I told you about. For this, we will generate a random integer, let's say between 1 and 1 million, for every DHCP transaction initiated by the program. Now, as I told you, we also need to enter the source MAC address into the DHCP discover. Here it is, right here. And also the client hardware address, which is actually the same MAC address, only in a different format. Since we need IP addresses for some virtual DHCP clients, we should generate a random unicast MAC address for each of them. This will be stored in the HW variable. To randomly create a MAC address, I decided to concatenate the standard 00005E part of the address with another 3 octets that will be generated by the randMac function. Now let's go into the Scapy interpreter and see what does this function return. So, Scapy using str, so str of randMac. Let's do it again and again. Okay, so each time we run this function, we get a different MAC address. Now using a slice, I am cutting off, notice the slice right here. I'm cutting off the first 9 characters of this string because I'm only interested in the last 8 characters. So these characters over here. And finally, I am appending these characters to the unicast prefix I have already entered, so 00005E. This way, I made sure I am passing a valid unicast MAC address into the packet. Now, although the client hardware address is actually the same address as the source MAC address, DHCP requires the packet to have this address in another format than the actual hex string. We can do this using the MAC to str function. Let me show you this in the Scapy shell. So, let's use MAC to str of randMac. Okay. This is the reason I have created this third variable right here. HWSTR, which stores the random MAC address that we've created in the format generated by the MAC2STR function. So in a format similar to this one over here. Now we have a completely valid DHCP packet. Okay, we have the packet ready to be sent to the server. To actually send it, we should use one of Scapy's functions. Let's see them again using the LSC function. So LSC. Since we are not only interested in sending the packet, we would also like to receive a response from the server. And since this is done at layer 2 of the OSI model, we will use the SRP function right here to do this. Also, as arguments to this function, we should pass the packet we just created. So this is it. The interface on which to send it. This is collected from user input. And the timeout in seconds to wait after the last packet has been sent. Finally, we should also set the verbosity level to 0 to receive no output. Now let's uncomment some print statements and run the application to see the results returned by the server when sending our packet. So let me uncomment this one, and this one. Okay, let's run the application. So Python dhcp sim.py eth1. Let's simulate a client. So 1 and eth1. Now, as I said in these comments right here, the SRP function returns two lists. We are actually interested in the first list, which contains a tuple. The first element in the tuple, let's see it. This is the first list. And notice that we also have a tuple. Notice the parentheses right here. So the first element in the tuple is the DHCP discover we sent. Let's see it. Okay, this is it, up until the comma. And the second element is the DHCP offer received from the server. So this is the one right here. Now in a DHCP transaction, after the client receives an offer from the server, it takes that IP address and uses it in a DHCP request to tell the server something like, okay, I agree with the address you offered me and I want to use it. That's why we have to extract the IP address from the DHCP offer we got and use it in a request packet. To do this, we have to use indexes and the fields of the packet. So we have index 0 because the tuple inside the list we received is the only tuple in the list, so it has index 0. Then we have index 1 because we're interested in the second element of the tuple, which is the DHCP offer. Then we should refer to the bootp layer, and from that layer we are interested in this field over here. So let's see the list again. Okay, let me find it. Okay, this is it. We are interested in this IP address right here and we should extract it. And we can do this using indexes and layers as we did right here in this print statement. This is actually the IP address that the DHCP server gave to our virtual client. So you can see it extracted right here. Okay, now to add this address to the DHCP offer packet, we have to create a new DHCP option. Let me show you. This is the option. It is called requested ADDR, and give it the value stored in the variable we just defined, the IP address. So offered IP. So we are actually passing this IP address received from the server in the offer packet to the request packet in this option right here in the DHCP layer. Okay, now the next thing to do is send the request using the SRP function. So after defining the request packet, which is almost identical to the DHCP discover packet, we should use the SRP function to send the packet on the wire to the DHCP server. Now let me comment these print statements we just used for the discover packet and uncomment some of these print statements for the offer packet. So this one and this one. Okay, now let's run the application again. So okay, eth1 simulate one client, eth1. Okay, so this time we get another tuple inside the list as we did before. This time the second element in the tuple is the acknowledgement packet sent by the server. This is it, which actually completes the DHCP transaction process. Now we have the confirmation that the client has indeed received the IP address. And also we can extract this IP address as we did before. This time, because I did a new transaction, another IP address is displayed, .2.3. We had .2.2 before. Okay. Another thing we can extract either from the offer or from the acknowledgement packet is the server IP address. This is located in the IP layer. Notice I've printed right here as the source address from which the packet came. So if we comment these print statements back and uncomment the server IP, let me run the application one more time. So ETH1 S1 ETH1. Okay, so we extracted the IP address of the server. This will be stored in this variable right here, server IP. Okay, let me comment this back. Okay, and let's save the application. Finally, remember that we created 3 lists before this function, this list over here. The all given leases list will store each IP address received from the server. That's why for each transaction we append the extracted IP address to this list. So let me find this. Okay, so all given leases dot append of offered IP ACK. This is the IP address received from the server, stored in this variable. Secondly, we append the server IP address to the server ID list in case multiple DHCP servers respond to our DHCP Discover packets. So this is some useful information too. We append it using the append method right here. Thirdly, we will populate the client MAC list with the MAC address of each of our virtual clients. We will use all this information later in our application. Finally, the function will return these 3 lists. Okay, so in summary, we created the DHCP Discover packet. Then we send the packet to the router using the SRP function. As soon as we get a response from the server, a DHCP offer packet, we extract the IP address given by the server from that packet using indexes and the appropriate layer. Then we use that IP address in the DHCP request packet and then send that DHCP request packet back to the server. And finally, the server responds with an acknowledgement packet from which we extract again the IP address and store it in this variable right here. Also, we can extract the server IP address from the packets we get from the server. Finally, we are adding the values we extracted from the packets to the 3 lists we defined up here, and then return those lists using the return statement.